starting a new unit. This unit is called Dilations and Similarity. Alright, so little spoiler alert, dilation, you guys might have heard that word before. It's when you make something smaller or bigger, reduction or enlargement. And similarity is when something's similar, unintended. Alright, but we got to review some stuff first. We're going to review our rigid transformations, our translations, reflections, rotations, and then we're going to have triangle congruency stuff that we learned previously. SSS, SAS, ASA, AS, and HL. That stuff's going to come back in this unit as well. So let's just first review. All right, we have translations. We're going to first translate the image using coordinate notation. So x minus 3, y plus 2. So that really means I'm just going to take every point, count left 3, up 2. So from point A, I'm going to go 1, 2, 3, 1, 2, boom. Put a point there, and that's A prime. Make that a little thicker, 1, 2, 3, 1, 2. So I did that from B as well, and I get B prime, and 1, 2, 3, 1, 2, and boom, that's C. All right. C prime. All right, so I left 3, up 2, connect all the points. So translation is just when you slide the shape. All right, and this orange triangle that I just made is the same exact triangle as the original one. It's just in a different location. Remember, all the angles are the same, all the sides have the same length. All right, so that was the first one. Next one is reflection over the y-axis. So ahoy bucks, remember the y-axis is the vertical one. And remember, images are equidistant from the line of reflection. All right, that's just a property of reflection. Think about when you look in a mirror, if you're 3 feet from a mirror, your image looks like it's 3 feet within the mirror for a total of 3 or 6 feet. So A, let's look at A. Notice how it's 3 to the left, so A prime will be 3 to the right. B is 1 to the right, so B prime will be 1 to the left, and C is 2 to the right, so C prime will be 2 to the left. All right, they're equidistant from the line of reflection. And remember, this red triangle that I just made is the same triangle as the original black one. It's just in different space. All right, it just flipped, different location, but still all the sides and angles are the same. All right. And then the last one is rotation. All right, this one is probably the hardest one. Is it super hard? I don't think so. It's the hardest one. Yeah. All right, so we're gonna rotate 90 degrees counterclockwise. So that means I'm gonna go that way. All right, so you guys can physically rotate your iPad. You guys can't see me rotate an iPad on the video though. So what I'm gonna do is notice how A is 3 to the left, 1. I'm going to just swap the order, go 1, 3. So I just need to go one quadrant over and swap the absolute value of the points. B is 1, 3. So I'm going to swap it to 3, 1, but go into the other quadrant. And I actually landed where A was. That's B prime. And then C is 2, 4. So I'm going to swap the order, go 4, 2, and end up in that quadrant right over there. And again, this green triangle is the same triangle as the black one, it's just been spun. All right. Now, why are these types of transformations called rigid? All corresponding parts are congruent. The triangles are still congruent. They're the same triangles. Remember, we had a whole unit about that. Okay, so that wraps up video 1. Stay tuned for video 2.